Good morning. Welcome to this session of Cleanroom Software Engineering with Django. My name is Francisco, and my intention today is that you get a very good idea of what Cleanroom Software Engineering is. I don't know, maybe in the future, in a party, they offer free drinks for those who know what Cleanroom Software Engineering is or something. Well, seriously, my goal is that you get to know Cleanroom Software Engineering today, together with its possibilities, its disadvantages, and above all, how Django can be used in the context of this method. This workshop is more about functionality than performance or middleware. I apologize for my English, and I also apologize because I will be checking my notes, so I won't miss anything that I want to share with you. And sometimes I'm going to be looking at the screen in my left. Okay, so let's start. Our agenda today is as follows. The first is that we are going to see is, do we really need another method, or is Francisco, why you come and disturb our peace of mind? We are so happy with our methods now. The second item is what is Cleanroom Software Engineering. Here we will see a theoretical overview of the method, and then we will start an exercise. The third point is, can the Django help with the method? And we will see a practical application of the method using Django. The fourth point is, can the method help Django? Can we use it in our Django projects? And finally, we will have part for conclusions and questions. Okay, do we really need another method? This graph shows the adoption of Agile practices. It is from 2015, the State of Scrum report, but still very valid. Things haven't changed so much. You can see that almost 95% of responding organizations, almost everyone uses Scrum, which is good. 4 out of 10 use Kanban, 2 out of 10 use Lean development concepts, 1 out of 10 use string programming, almost 1 out of 10 use feature driven development, and 1 out of 20 use other methods like unified process, family, and 1 out of 100 use other like team software process, waterfall, although it's not a method, it's a lifecycle model, and also 1 of 100 use the dynamic system development model. Dynamic system development method, and the same for Crystal and Crystal Clear. Now let's look at the other graph. This one is from State of Scrum 2017-2018, and it talks about the value, what executives value most about the Scrum projects. Okay, so you're going to tell me, what do executives know? And they may know nothing, but they are the ones that approve the budget. So let's see. If we see here, 7 out of 10 appreciate the value delivered to the customer, and 6 out of 10 appreciate the flexibility and responsiveness of the method. And then we move to another part where 4 out of 10 appreciates quality, transparency, scheduling deadlines, and visibility. And at the bottom, we have cost, innovation, and improving with 3 out of 10. Well, let's focus on quality. Quality is something that is, of course, appreciated in agile methods. Actually, the Agile Manifesto says that continued attention to technical excellence and good design improves agility. And it is correct because nothing is less agile than fixing defects all the time. Okay? Agile brought us many practices, but many good practices related to quality, and like continuous feedback from Scrum, or pair programming from string programming, or clean code, concepts refactoring, and testing practices like test-driven design, unit test, of course, automation of tests, and the whole part of DevOps. Okay? So it seems like everything is okay, right? Well, let's see. This is a master thesis from Petro Kalane from South Africa. And basically what he says is that Scrum is agnostic in quality assurance practices. And he sees it as an incomplete method. It does not perfect any software quality assurance techniques, and it is incomplete. Okay. And he concludes that Scrum needs to be complemented. It's like empty buckets which need to be filled. And it is not different from what the creators of Scrum says, that it is a framework. Okay. So the important conclusion here is that the Scrum needs to be complemented, especially with quality practices. And this is reflected in the fact that almost 8 out of 10 organizations use complement Scrum with other approaches. Yeah. So how can we complement Scrum with other practices? Well, one idea is to use extreme programming and peer programming practices or other methods. Let's see. This is something from Capers Jones. Capers Jones is a specialist in software engineering. He specializes in measurement, and he has a lot of publications about statistical studies. It is the most reliable source of statistical studies in software development. So what does Capers Jones says? It says that although peer programming is good, it is more efficient to use static analysis and inspections. Okay? And another conclusion is that testing only finds a third of the defects. That when we use test cases, when we apply test cases, when we test, we also inject defects. And as an average, we have an efficiency removal of 85%. And for every 200 lines of code, we will inject about 2 defects. I want to confess I never liked the term bug because it relieves from responsibility. You know, the term came about because there was a moth eating the wires of this ENIAC computer and causing failures a long time ago. And I like the term technical debt better because it makes us think more about what is our responsibility. I won't dwell too much here. I just want to emphasize that defects are injected at any stage of the life cycle. It's the same if we use an iterative and incremental life cycle. there will be always analysis activities and design activities, even if we do them at the IDE. Agile methods have reduced documentation, but defect repair is a part where we inject about 8% of the defects. I'm not going to go into much depth on this slide, which is also a study of the 90s. I just want to emphasize something that is obvious to all of us, that defects are more difficult to repair when we are already in production. And finally, in this part, I want to emphasize the effectiveness of code inspections. If we look at the graph, the blue line shows how we are injecting defects, the life cycle, and how if we do not perform, this is the pink line. If we do not perform inspections, we are leaving defect removal to the end. So, what is Cleanroom software engineering? Cleanroom software engineering is a method, development method that emphasizes the production of high quality software in an economical manner, okay, without incurring a lot of costs. An important part is that it has its theoretical foundation in mathematics. And the name is just curiosity. It comes from the hardware industry, the hardware production plants, and is named after the clean rooms where you have to keep the clean air and avoid any contamination. Now, this is a short graphical clean room software engineering history. The creator of the method is Harlan Mills. Harlan Mills, we used to say the only way for errors to occur in a program is by being put there by the author. No other mechanisms are known. Programs can acquire bugs by sitting around with other buggy programs. He has his sense of humor. Harlan Mills earned a PhD in mathematics at Iowa State University and became a professor of computer science at the Florida Institute of Technology. After that, he became a research fellow at IBM and applied the ideas from the most influential thinkers of the period, like Parnas, Nicholas Weir, and Dijkstra, along with ideas from mathematics to software development. Actually, there is an award with his name at the IEEE Computer Society, and his method, Cleanroom software engineering, was used with success by organizations like NASA and IBM, among others. Now let's talk about the Cleanroom software engineering principles. The first one is that for this method, a program is viewed as a set of rules that express mathematical functions. We will go into more detail later. The second one is the requirements specification and design is made via special construction bricks called boxes. Okay? Third one is this method emphasizes code inspections using the technique of peer reviews and as a way to find defects. Fourth one is that it is the life cycle model. This method used is incremental as well as an iterative development. For the testing part, the method used is statistical sampling and quality certification. So programs are rules that express mathematical functions. And when we specify a program, we specify a function that maps an input sequences to an output space. This will allow us to achieve completeness because we will map each element of the domain to at least one element of the branch. We will also achieve consistency because each element of the domain will map to at most one value in the branch. So we won't have two answers to an input, put it that way. And using peer reviews, we will also achieve correctness. In mathematical analysis, the general concept of function application or mapping refers to a rule that assigns each, as we said, each element of a first set as a single element of a second set. If this looks very theoretical, don't worry, we will go to our practice later. Okay? And now let's talk about the construction bricks, the boxes. We said we will have three boxes: a black box, a state box, and a white box. Okay? The black box basically has to deal with data, input data and output data. It is called a black box because when we design it, we don't care about what is inside, just what enters, what goes out. The state box reflects the behavior of the system, which we can view as a Markup chain. And finally, the white box or clear box is the procedural part where we put the code that will create a response from the system. The black box. Here, we talk about stimulus and responses, okay? Which could be, for example, menu option in stimulus could be, for example, a menu option selected by a user in our system. And the response could be an email sent or a template presented. Okay. Also could be, stimulus could be a cron job launched, etc. An important part is the history, which is this age. We can see the important part of the history in an example of Blackbox, which is a calculator. If I enter the digit 4, it is not, the result is not the same if I enter 5 times before, or if I enter previously 3 plus before or 2. So history is important, and also order is important here. Now the state box. The state box can be implemented as a state transition algorithm. If we see it from the object-oriented paradigm perspective, we could have a singleton object implementing the state pattern for the whole system. In the procedural paradigm, we can have a set of functions and a way to keep the current state of the system. Finally, we have the white or clear box. In object-oriented paradigm, this will correspond to the implementation of the methods in an object. In Django, it is implemented in our views and our models. This is where the logic of the code goes. Okay, we have the instructions we know very well, which are here as pseudocode. Now, we said that here we use statistical testing because in this method, the software is built as an stochastic model. There is probability related to each event, okay? We don't know if the user is going to do things in order, and we know it with a certain probability. We know with a certain probability that the database will be available, etc. Okay. So, for example, we have a system with 10 possible inputs, which in the worst scenario could be in disorder, we will have more than 3 million possible permutations without replacement, which is impossible to test. So what we do in this method is to develop a usage model of the system, and then we estimate the probability of each transition. From here, we will design test cases from the most probable scenarios to the least probable. We will also have to develop different usage cases or usage scenarios for different users or actors and for special cases. We can then represent these scenarios using Markov chain models. Now, statistical sampling is probably used in our industry, for example, in a bolt factory. You don't have to measure every bolt in order to find out the quality of the production, but instead you will use statistical sampling. It is also used when it is impossible to measure the whole population. Think about, for example, sea pollution. You have to take a sample. And in software, you know the saying that goes, the only exhaustive test is the one that leaves the texture exhausted. Let's move to Markup representation. I will stop here a lot because you are probably familiar with Markup models. The Markup model represents states of use connected by transition arcs. Okay? That represents possible stimuli to the system under test. They are probably assigned to each arc. That's what we were talking about. And the probability represents how much transition arc can be selected from a state. For example, here you can see the probability associated with the transition from A state to the end state, which is 20%. Now, a little more about this Cleanroom software engineering process. We will start with an analysis of the requisites. Then we will we'll move to the functional specification, and in parallel we will develop the usage specification, and there we can plan our iteration, okay, and start development, and start to plan the test with the usage modeling, and then we will move to the statistical test certification. I'm sorry, I will like to give more time to testing, to this part, to the testing part, but it will require a dedicated time. Finally, this method is compatible with Agile methods, with user stories, use cases, CMI, ISO 29110, unified process, or object-oriented paradigm, event-oriented paradigm, and other methods and disciplines. Okay, now that's it for our theoretical explanation. Now let's get into our sample. I will switch my screen now, and we will share with you another one. Okay. First, I want to say that I use this method with an organization where the software development area had 5 developers, a tester, and a scrum master. They had a history of customer complaints because of defects, and they also will struggle at the beginning of the project in order to find out what every developer be responsible of. We then use a spreadsheet, and like this one that we are going to see now, and it took us several days, but we could finish a specification for a module that will do a teacher assignment to courses. They went to develop the software and deliver it to the customer, and the results were so good that even surprised me. They didn't have a problem with the distribution of job because the top-down approach we will see now, and it was the customer, the first time that their customer didn't find a defect. Now, I ask you if it's possible to open your own spreadsheet and try to do it at the same time and try to find the answers by yourself. Okay? Let me share it with you again because okay. Now this for this example, let's say we are a company that buys us sells used vehicle over the internet. We want to have a page on the internet where the person who wants to sell his vehicle can obtain a previous valuation at the moment. To do this, you must register first. Once you register, you can enter the data of your vehicle, the year of the vehicle, the model, and the condition, and the system will calculate a range of value, from X to Y euros or dollars. And when the owner consults the valuation, he or she can schedule an appointment with a salesperson for a physical appraisal. And the vehicle owner can reschedule the appointment to a date where they're available salesman. After the appointment with the commercial area, the owner can confirm that he or she is entrusting the sale to the company for when he must sign an online contract, and the company will notify the owner when the sale has taken place. After the sale, the accounting department will make a deposit to the client minus the commission. Okay. From this description, you will agree with me that is not uncommon that this is the level of detail that we get from the users. We will develop our requirements. We could use user stories or even use case if you want. For this example, we will simply use a list of requirements. Now, make here a list of our requirements. If you can do it in parallel, that would be great. Okay. And the first one that I think of is that the system must calculate the value of a vehicle in a range. Okay. And we will assign it an ID, which is R1, requirement 1. And the second one for this part is the system must register users, okay? And we will assign it a R2, okay? Let me see. And what else? Well, the system must allow registered users to consult the evaluation of the vehicle online. This would be requirement 3. And what else? The system must give the option to make an appointment with the salesperson. Okay. And this is this will be the requirement 4, and so on. Okay. Users can unsubscribe from the system, which is 5. User may entrust the sale to the company, which is R6. And then what else? The company will notify the owner when the sale has taken place, which is R7. And that's enough. Okay. So we have these 7 requirements that they are at a high level. Okay. So what the method says is now we have to find out what are our inputs to the system, which are called here is stimulus or stimuli in plural, and then what are the responses to those stimuli? Okay, so let's give an example. I'm going to use also a code here. Is stimuli one, stimulus one, sorry, and let's see what it could be. Well, let's say that the owner of the vehicle, because he's not yet a user, he enters into our main page. Okay, we'll leave a column here for variables if we use it, and then we will see what other stimuli we can. Well, let's move to responses. What is the response that the owner will get if he enters our main page? Well, this is a very simple one. Let's say we'll show our landing page or our main page. Okay, this is response one, and we will have to annotate the stimulus. We'll see is one. Okay, and so we will move to the next stimulus, and which is the owner wants to register as a user, okay? And the third one will be the owner enter his data to register as a user. I know we have a module for authentication in Django, but still we have to take this into account. And the next one is the owner cancels entering her data, which could occur. And let's say the owner clicks on the link received by mail. We send him a mail and he clicks on it to be registered. And then the owner logs in, okay? Once he logs in, he can select enter your vehicle data, okay? And what else can he do? He then registers the vehicle data. Then he will select, make an appointment, for example. Then he will make an appointment with a salesman. Then, or he could cancel the appointment later, okay? That could happen too. Or what else can he do? He can change the appointment, okay? We're given an option to change the appointment. Also, the salesman, after he meets with the customer and checks physically, he checks the vehicle, he wants to enter evaluation, the final evaluation, okay? So he selects enter evaluation, then he enters evaluation, then user selects entitled sale because he needs to sign a contract so the company can sell his vehicle, and the user effectively entitles the sales to the company. Then the salesman confirms after some time, the salesman sells the car, so he confirms sale. And then what can happen is that that will be the end of it, okay? So we will assign an ID to each of every one of these stimulus, okay, just to identify them. And now we can move to responses, okay? We saw that, for example, if the owner enters into our main page, the response is showing our main page. And what other response will we have? If he wants to register as a user, then we will show our registration page, or we could notify him that he's already logged in, okay? And what else? What other response? If he enters his data, then we will show the success page and set mail. Or what if he's already registered or the mail is already registered in the system, then we will show him an error message. So we have both possibilities here, and then we can use a variable that is let's call it is ready register. Just as an example, what are variables for. Okay. Then next response, we show him a login page, and when after he clicks on the mail, then we shows the page for initial evaluation. Another response, we show him the result of this calculation. We show the page for appointments, and after he selects a schedule a time, then sends the email to the user and salesman. And also, if he cancels the appointment, we will send a mail. Those are typical responses that we could find in this type of system. Okay? If he wants to change the appointment, we could tell him cancel it first, because we need to cancel it and then make another appointment. And then if the salesman selects enter evaluation, we show the evaluation page. After he enters the data, we notify the final evaluation, and then if the user selects entitled cell, then we show him an entitlement page. And if he signs the contract, then we send mail with the contract data to the user. And if the salesman selects confirm sale, we will show the page of the confirmation of the sale. If the salesman confirms the sale, we will confirm and send information by mail to the user. And that's it. Okay. So we will also assign a code here for every response, and we can put the stimuli related to every response. Okay. And now we have finished with all the possible stimuli and responses of the system. This is our top-down approach. Okay. Now, what are our valid sequence of actions? Okay. We run the final, the happy path is, is that the owners goes in order. So he enters into our main page. He selects registering as a user. He enters his data, and the data is correct. And he clicks in the mail at the time he receives it, and he logs in. Then he selects the option of enter your vehicle data. He enters the data and it's correct. He makes an appointment. The salesman then goes to visit the client and then enters evaluation. And then the client and the user selects entitled sales. He entitles sale to a company. And then the salesman sells the vehicle, and then he confirms sale, and that's it. Okay, that's the happy path. But is it realistic that we expect the happy path to occur, or are we very optimistic? For example, can the user try to register twice? Yes, I know the authentication systems can take a bit, but here, can the user try to change an appointment without having confirmed one? it could happen? Or what if the salesman try to enter evaluation, but the client, the user, hasn't entitled the sale to the company? What other scenario can you think about that goes out of the happy path? Okay, it can happen. And the important is if the happy path changes and the user takes another path, do the response changes, like in the calculator? Is it me that is very pessimistic, or are we optimistic, thinking that everything will happen as planned? Okay. Have you ever had a friend or family that asks you for help with the mobile or with the computer, and you say, just restart the system? I have done it many times. Why does that happen? Because sometimes the state of the system is inconsistent. And if you reset it, then you get to a consistent system state, and then everything works as planned. Okay? But of course, if we consider that we are being too optimistic and we should uh, take into consideration every path possible, then we get into another problem. Okay, because if let's see that if the owner enters into our main page and then wants to register as a user, that's the stimulus 1 and the stimulus 2. Okay, that's two stimulus at the same time. Okay, that's but if we consider 3, then we have 3 possible stimulus, and we have to take into consideration that we will have, like, for example, S2 and stream. Okay. Okay. For example, we will have here that it could change, and stimulus 2 could be at the beginning, or stimulus 3, and we talk here about permutations. Okay. And if we only have 10 stimuli or inputs, and only 2, we consider 2 at the time. For example, let's say here 2 at the time, then we are talking about 90 possible permutations without replacement, of course. But if we want to consider 3 at the time, like we had before, we have 720 cases. For at the time is more than 5,000 possibilities, and so on. So what do we do? Are we going to ignore this scenario? Are we going to try to find out which are the most probable paths that the user can take, so our system don't get into an inconsistent state? Fortunately, Cleanroom software engineering has a technique for this. It's called sequence development. Okay, so let's ignore this for a moment. Okay, and the technique calls it the length. The length is the number of a stimuli that you consider at one time. So we consider 1 here, 1 here, 1 here, 1 here. So this is the stimuli of length 1. Okay, but if we do this, we have these possible sequences at the beginning. Okay, so 1, 2, 3. These are the stimuli we have here. Okay, and then if we consider the length 2, we will have the same, but length 3 will have permutation of 3, and so on. Okay, so the technique says that then we must give a response for every stimuli. Okay. Now let's put a special stimuli here, which I call S0 or initialization, and then we will try to give a response for this. Okay. Let's say that we need to initialize the system, and also it serves as a starting point. Okay, so that's and that everything that happens before this, we will have a response that we would call illegal. It's a special response, and so the first one, except for the initialization, is illegal. Okay, and the response here that we do when we initialize is we will show our landing page. Okay? So the method, we will have to give an answer to any of these. And what does the technique help us with the number of permutations? Okay, for the length one, we will consider each one of these before the system initialization is illegal. So we won't consider them, okay? And so let's go to length 2, and then we have system initialization. Then we can consider some sequences that are valid. Okay, let's see here. The 0 and is 1, which is the owner enters into our main page, and the owner wants to register as a user. Then we have response 1. This is we will show our landing page, and so on and on. Okay, so we will. But the technique says that we only consider stimuli that are not illegal or has an equivalent. Okay, if a sequence has an equivalent, then we will have to process one. We don't repeat, so it won't go further to another length. But this is how the technique goes. Okay? And also the technique the states of the system could be the stage we are now, like so in our main page, or the response we're giving at every moment. And the white boxes is we'll put here the code for every state, and then we will have our code. Okay, so that's how it works with a spreadsheet. Okay, now we're running out of time, and now I want to share with you the answer. Can Django help us with this? Okay, so say I'm going to share my screen, and then sure. Okay, we have a database here. Then we have the stimuli here that is the same ones that we saw there. We have the responses, okay, here, including illegal and null, which are special cases. And we have the requirements, of course, that we saw, and that's okay. And here, Django helps us as a database. Of course, it's better to handle this way than in a spreadsheet. Okay, but now let's go to the best part. Okay, so if we see the site here, and these are 7 requirements, and then we have the stimuli here. Okay, and the responses. We see that we have the name of the response, description, and we have the requirements related, and we will see now the sequences. Okay, so the sequences is what we were seeing before. Okay, and then we have S0, S1, S2, S3. Now I have put a response for all of them. We said that nothing that happens before system initialization is legal, so all of these are illegal responses. Okay, and then we have a response, valid response with S0, which is show and then display our homepage. Okay. Then, but where the help comes from Django is here, because we have 20 sequences here at level 1 or length 1, but once all of them are finished, and I'm going to finish this one, and say yes, okay, then we see that we have 40 sequences, okay? So the system has calculated, and for the only valid one here, we have the next sequence length, okay? So we have a zero, okay, which will be, for example, a null response. Then we have a 0 S1, a 0 S2, and so on, okay? So the system will allow me to calculate and elaborate the sequences once I have initial level. So it will help me like this. It will also help me to find out which sequences I haven't yet resolved, okay? And what are the legal sequences, what if we have node sequences or equivalent sequences, okay? So, and the most important part, the sequences that are going to be the happy path is the canonical sequence. Here we have like this one, this is valid sequence. These are not, because they are not finished yet, okay? So we will see here only the home. Now, let's see another example. I will let me change the application here, 101. And then here we have another example. We have, this is for another application. We have here 196 sequences, okay? And we have the canonical sequences that are only 29. This is only 29 cases that we have to take care of, and that's all. And we can also see which sequences are illegal. We can check what sequences have an equivalent response, so we don't process them twice. We make the equivalent to another response, okay, and so on. So this is how Django has helped me to use this method, Cleanroom software engineering. Okay. Now for the part that can we use Django for this in a project? Okay. We have this generate code item that, or menu option, that is going to take everything that we have here and it's going to generate the state transition code, and also will take care of all equivalent and illegal responses. So if he finds this sequence 00114 in this case, then he will make it equivalent to this one, and so on, okay? And if we do generate the code, then we have this code that I'm going to show you now, because we're running. And with this, we will finish. Okay. So we have generated this code. Okay. I won't get into much detail here, but this is all automatically generated. This is the state transition algorithm. Okay. It receives the option from the menu. Okay. And sometimes an item ID. And then we will have a dictionary of all the sequences that are canonical, they are valid at the end, and the function they are going to call. Okay? This is all automatically generated. Okay? And we also will see if we have to change the status after the response. We'll take care of it, and then we will also take care of the sequences that are illegal or if they have an equivalent. Okay, so let's see one of the responses. For example, this is a response that shows the login page. Okay, and this is something that you know very well, better than me, but it returns a page and with some parameters. This code is we put it first in every response. So we take it there and we only put it here. But we have for show login page, we have the sequence related. Okay, so what I did is to put the state of the system into the session. I don't like it very much, but so we're taking care of the session, the state of the system in the session. So every time a stimuli is received, it is added to the session, and then we see what to do with it. Okay. So now for the final part, let me show you what it looks like. This is a system we're going to deploy up soon, and this is a real case. So we have here like options, and every time we select an option, it goes through the state transition diagram, and I'm sorry, the state transition algorithm, and then it makes a response that corresponds to what we have. For example, if we have an illegal response, it will show us here that it is illegal to the user, and so we will take care of all the system consistency. And I think I'm out of time, so thank you very much for attending this workshop, and